Hey peeps, Wade here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today I'm going to be taking you through a question on the exponential graph which was sent in by Isona. So let's jump in. So it says the point A, which is 3 and 54, lies on the graph of f of x, which equals 3 to the power of x plus p minus 27. Now this function is an exponential function. How do we know that? We know that because we've got a base to the power of a variable, which is x, and then plus p is a horizontal shift, so a left or right shift, and then minus 27 is a vertical shift. In this case, it's a vertical shift downwards. Okay, in an exponential curve, we also only have one asymptote, and that asymptote is defined by this value over here, minus 27. Okay, so let's just do a quick sketch of this graph. And we know that our asymptote is minus 27, and that is going to go through the y-axis, so it's a horizontal asymptote. Okay, and that gives us y equals negative 27. We expect that our graph would probably look something like this. Okay. Right, first question says to us, determine the value of p. Okay, so the function is f of x equals 3 to the power of x plus p minus 27. We are given a set of coordinates, and those set of coordinates can be used to help us solve for the value of p. So to do that, we're going to sub in coordinates a, which is 3 and 54. So in f of x, which is our y value, will be 54 equals 3 to the power of x is 3 plus p, and then minus 27. Cool. Now to solve this, we want to try and get this section here by itself, and to do that we'll take the minus 27 across to that side, and we get 54 plus 27, which gives us 81. And so 81 will then equal 3 to the power of 3 plus p. Cool. Now we've got an exponential equation that we can solve quite easily. We know that we need to get the bases the same. So if the bases are the same, then we can drop them and equate the exponents. So our prime base is 3, so we need to try and get 81 into its prime bases. And if we do that, we get 3 to the power of 4, which equals 3 to the power of 3 plus p. Now that our bases are the same, they can fall away, which leaves us with 4 equals 3 plus p, and then it's a linear equation, so we can take the 3 across, leaving us with 4 minus 3, which is 1 equals p. Cool. Now you've solved for p, and that scores you 3 marks. So I'm just going to write that equation out in full now that we know the value of p. So that will give us f of x equals 3 to the power of x plus 1 minus 27. Minus 27. Okay, so what that x plus 1 has done is that shifted our graph horizontally, so left or right. Because it's plus 1, it works in the opposite. We expect that it would go to the right because this is where all our positive values go, but in actual fact, when we solve it, it actually ends up going to the left. So this is going to be a 1 unit shift to the left. Okay, the next question, 7.2, says to us, determine the range of f. Okay, so now a range in an exponential graph is quite easy because it's defined by your asymptote and then either to positive infinity or from negative infinity up to your asymptote. In this case, it's going to be from our asymptote of negative 27 up to infinity. And remember, range refers to the y values. So in this case, we can say y is an element of between minus 27 and positive infinity. Round brackets for both because we can't include those values. Another way we could write it is y is greater than negative 27. But this is a much better way to look at it. Right, and then the last question, 7.3, says to us, graph G is obtained by reflecting the graph of f about the x-axis. Determine the coordinates of the y-intercept of G. Now let's not overthink this question, because all we're doing is we are reflecting the graph about the x-axis, and what that means is we essentially think of it as folding your paper in half from top to bottom, so just folded essentially across the horizontal line. So what happens in that case is our x values stay the same, but our y values become the opposite. So to solve this question, what I'm going to do is I'm going to work out what the actual y-intercept of the original function will be, and then we can work out the y-intercept of the g-graph. So to do that, we know we must let, for the y-intercept, we let x equal 0. So we're going to say, have our function, which is f of x equals 3 to the x plus 1 minus 27, and then for y-intercept, x must be equal to 0. So we can call f of x y, which will be equal to 3 to the power of 0 plus 1, which will just be 1 minus 27. And then if we solve for that, we get y equals 3 minus 27, which is negative 24. Cool, so then our y-intercept for the f graph is 0 and negative 24. So therefore, the y-intercept for the g-graph will end up being, remember, the x stays the same, the y becomes the opposite. So if it's negative 24, it's going to be positive 24. And that's that. You've got the y-intercept of your g-graph, which has now been reflected about the x-axis from the f graph. Before I go, I'd just like to give a quick shout out to Isona. Thanks for sending in this great question. I'm sure many learners will benefit from watching this video. And remember to visit our website for more of these epic video tutorials. And if you can't find the answer to your question, respond with a personalized video just for you. Until next time, stay epic.